looking at section 5.7, scatter plots and trend lines. Okay? Now, a scatter plot is a graph that relates two different sets of data by displaying them as ordered pairs. Okay? Most scatter plots are in the first quadrant because you always, most of the time, have positive numbers. Here, you can use scatter plots to find trends in the data. I want you to sketch all three of these, and we'll talk about all three. All right? The scatter plots show three types of relationships that two sets of data might have. Okay? So here, in the first graph, we have, this is when y tends to increase as x increases. So as x increases, y increases. When that happens, you have a positive correlation. Okay? As the x increases, the y increases. That's a positive correlation. For the second graph, you see the plotted points are going in the downward direction. As the x increases, the y decreases. You see that? As the x increases, the y decreases. That is a negative correlation. Okay? And then the last one is when there's no relation, there's no correlation at all. Okay? It's just plotted points all over the place. All right. So an example of a positive correlation, as the x increases, the y increases. How about if you are driving a car? Okay, you're going on a trip, and the longer you are driving or riding in the car, the longer you're riding in the car, time riding in the car, as that increases, what happens to the miles you've driven? It increases also, right? So the longer you're driving, the more miles you drive, right? That's a positive correlation. Thinking about that as a negative correlation, the longer you drive the car, right, the less gas you have in the tank. That is a negative correlation. Very good, very good. And then for no correlation, how about the year you were born and your shoe size? Or the year you were born and the number of brothers and sisters that you have. No real correlation yet. Does that make sense? All right, very good. So problem one is making a scatter plot and describing its correlation. So here I want you to write down the table and we're going to graph. All right, so here we are graphing gasoline purchases. Now the first thing we need to do is we need to figure out which one is the x and which one is the y. And we do that by figuring out which one is the independent variable and which one is the dependent variable. Okay, so remember, let's see, the x is the independent variable. That's the independent variable. And the y is the dependent. Y is the dependent variable. Now, the way we can tell the difference is that the x value, the x variable, or the independent variable, is the one that does the affecting. Remember we talked about this a while back? This one does the affecting with an A. Okay? And the y value gets affected. Okay? So the x causes the y to change. Got it? So, what do you think? Which one is which? Yes. Dollars spent is X?
No.
Think about when your parents go to the gas station. Right. So first they pump the gas, right? And then, however many gallons they put in there determines how much they're going to spend, right? Or how much they have to pay. So here, gallons bought is the X, and dollars spent is the Y. Does that make sense? So now we'll just put it on our graph. So down here on the x-axis, we have gallons bought. And that is, just gallons bought. And then dollars spent. Okay. Sorry, that here. Okay, so now we need to put our intervals on here. Okay, and no, you can use different intervals on the X and the Y. Okay, yes, you can do that. So, gallons bought, the lowest is 1.1, the highest is 3.3. So let's go out to fours. Let's go out to four. So 1, 2, 3, 4. And then for the dollars spent, the lowest is, well, it doesn't matter what the lowest is because we just start at 0, right? And then the highest is 13. So let's see what we'll fit in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14. Oh, perfect. 2, 4, 6, 8, 10, 12. And then you graph. All right, so after you plotted your points, there's your graph. So, what does it look like? This is a positive correlation. Very good. This graph has a positive correlation. Positive correlation. And that's all they're asking. All right, so a trend line is a line on a scatter plot drawn near the points that shows a correlation. Okay? When you draw your trend line, okay, notice that that line does not connect the dots. Okay? The line does not connect the dots. The first graph shows an increasing trend line, and the second graph shows a decreasing trend line. Now you can use a trend line to estimate a value between 2 points, or between the points, or between the data. And you can also use that trend line if you extend it to make predictions. Okay? When you are estimating within the data, that's called interpolation. Okay? When you are making predictions about what happens outside of the data, that is called extrapolation. Is everyone clear?
Can you do interpolation again?
So problem 2 is writing an equation of a trend line. We want to make a scatter plot of the data, and we want to draw a trend line and write its equation. And then we want to approximate the body length of a 7-month-old panda. And we want to use the graph to extrapolate the body length of a 1-year-old panda. Okay? So right now, copy down your data. So, the first thing we need to do is figure out what is going to go on the x-axis and what is going to go on the y-axis. So what do you think? Which one is the x and which one is the y? Jacob?
The age is the X.
Yes. Age is the x and the body length is the y. Very good. So now we put that data on our graph. Okay, I think I need to move this down a little. So for the age, we're going from 0 to 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Good. 2, 4, 6, 8, 10. And that down there is the age in months. Okay? And the body length in inches goes here. Body length in inches goes right there. So let's see, 8 to 29. So let's see, 2, 4, 6, 8, 10. 2, 4, 6, 8, 20. 2, 4, 6, 8, 30. So remember, when you put your trend line on there, the line has to be near most of the points, okay? And it is only an estimation, okay? So my estimation could be a little bit different than yours, okay? But it should be very close. Let's see. All right, so we are going to draw a trend line. Okay, is that a good one? No.
No.
That's not a good one. Because look, they're all on the top, right? So let's see. Would this be a good one?
Yes.
No. Because it doesn't follow the trend. How about this one?
No.
No. So, all right. So we want to follow the trend. Is that good?
Yeah.
Okay.
It'll work. It fits.
That's good. I think that's good.
All
right.
right.
So there is my trend line. Okay, and don't forget your arrow, because that bear can still keep on growing, right? I know it'll stop at a certain point, but after 1 year, it's still going to keep on growing after 1 year, right? So, all right. So there's our trend line. Good estimation. The next thing we want to do is we want to write an equation. What do I need to write an equation?
Numbers.
Slope.
And a y-intercept.
Well,
Oh, no.
we're not going to use the y-intercept here because, that's okay. We're not going to use the y-intercept because this was an estimation, right? We're going to use 2 points on the line, okay? So we're going to use the 2 points on the line to find slope, and then we're going to use one of those points. In which form?
Point slope.
Point slope. Very good. Very good. Okay, so slope. First thing we want to do is find slope. And that is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. In order for us to do this, we need to choose 2 points that are on the line or close to it. It just so happens, there's one, there's one, and there's one. Okay, is everybody clear? So I'm going to use those two. I could have used that one, that's pretty close, right? But this one's closer, correct? All right, so what are those ordered pairs?
16.7.
This one is 4, comma,
16.
16.7. Very good. 4, comma, 16.7. This one is 8, comma, 26.5. And there are the points I'm going to use to find my slope. You got it? All right. So now we substitute in. So we've got 26.5 minus 16.7 over 8 minus 4. 9.8 over 4. Now, because we're dealing with decimals, their slope, it is okay for it to be in a decimal form. Okay? So, what is 9.8 divided by 4? 9.8 divided by 4? What is it?
2.45.
Okay. Exactly? All right, so there is my slope. So once you have your slope, now you're going to choose one of these 2 points. Does it matter which point I use? Huh? No, it doesn't matter. You can use either one of them. You should get the same equation, right? All right. So let's just use, all right, 4 comma and 16.7, right? So which formula am I going to use? Point slope. And point slope is what?
Y minus Y1 equals 10 times X minus 6y.
Very good. Very good. Nice and together. Okay. So now we're going to take the 4 comma 16.7 and put it into our formula. Remembering that this is the X and this is the Y. So we have Y minus 16.7 is equal to the slope, 2.45, the one we just found, times X minus 4. And there's your point slope 4. Good? Now you just solve for Y. Very good. Now we solve for Y. Help me out with the calculators, okay? So we distribute first. And we end up with Y minus 16.7 is equal to 2.45x. What's 2.45 times negative 4?
Negative 9.8.
All right. And then we want to, very good, on both sides. And Y is equal to 2.45x plus what? 6 point. And there is your equation. So now we need to answer the question. It says, what is the approximate body length of a 7-month-old panda? You can put 7 in for X and then solve for Y. But I want us to use our graph. Okay? So we are going to use our graph to estimate the size or the length of a 7-month-old panda. So what you're going to do is you're going to go to 7, which is right there, right? Then you're going to go up to your line. You're going to go up to your line. What?
About 24.5.
So we're going to go up to our line, and then we're going to go from there to our y-axis. So here you can see that a 7-month-old panda is about, let's see, 23 is right there, so maybe 23 and a half, right? Maybe 23 and a half. So a 7-month-old panda could be about 23 and a half inches long. Got When we did this, we were estimating within the data. So what is that called? Interpolation. Very good. Interpolation. Now the next thing says, use your graph to extrapolate the body length of a 1-year-old panda. Okay, is 1 year in the data? No, 1 year is not in the data. So that's why it's extrapolation. How do I change that question to make it work? Okay, very good. We would change it to 12 months, right? So here's 10, 11, 12. So here's 12. There's 12 months, right? And we will go from the 12, and we'll go up to our line. But if you'll notice, our line is not there yet. So we have to extend our graph. So we will extend the graph. Okay, is that straight?
Yeah.
All right. So we will extend the graph, and now we'll extrapolate. So we will go up to our graph. And then we will go from that point to our y-axis, which is about right there. Everybody with me so far? Now you have to extend the y-axis. So this is 30. That's times by 2. 32, 34. So this is about that, because I think I have too much space in here. So that's about 38 inches for a 1-year-old